Okay, so let's look at an example problem. I haven't actually talked about the types of collisions yet, but I am going to introduce one of them right here. So this type of collision is a perfectly inelastic problem. And what we have is we have a 1 kilogram cart sitting on a frictionless track. A clay ball hits it, it sticks, and we want to find the final speed of the cart ball system. It looks like it says cart ball system. Perfectly inelastic problems, if you didn't pick it up from context, are ones where they stick together. They don't bounce off, they stick together. And actually, clay is a really common indicator of these kind of problems. For whatever reason, they always like put some kind of like clay object into them. Probably because when you throw clay at stuff, it has much more of a tendency to stick to it, where if you did it with like a rock or a dart or something, you're a lot more likely to have it bounce off. So at least in ideal worlds, clay always sticks to whatever we throw it at. So we're going to do this problem mathematically, and we're going to try and predict what's going to happen here. We could definitely do this with the graphs. By the way, we could say that the momentum of this one is like half, but it's 12, so gross half over. Okay, I'm not going to do that because I don't have enough room for it. I'll just do this mathematically. We have this object here, and it starts with a momentum that is equal to mv, and that momentum would be 0.5 kilograms times the velocity of it, which is 12 for a total of 6. Now the cart also has its own initial momentum. Its mass is 1 kilogram. Yeah, 1 kilogram cart. And its velocity is 0. So its initial momentum is 0. So based on that, the total initial momentum, pi, is equal to 6 kilogram meters per second. That means our final momentum has to also equal 6 kilogram meters per second. Let's set this up one slightly different way. I'm going to say we have our mass of our cart times, or of our clay ball, mass of our clay ball times our velocity of our clay ball, plus the mass of our cart, I'll just cart, times the velocity of our cart. Those two momentums at the beginning, momenta, I guess, are going to be equal to the mass of the clay ball cart and the velocity of the clay ball cart. So mathematically, we already decided that this guy here is 0. Therefore, the entire thing just gets scrubbed because it doesn't matter what the mass is. If it's multiplied by an initial velocity of 0, it has no momentum. So then we just have mass of the clay ball times the velocity of the clay ball equals, I'm going to expand this out and turn it into mass of the clay ball plus mass of the cart. And then they have the same velocity because they stuck together. And that's probably the sticking point for a lot of students. For problems like this, when they stick together, they try and figure out what the velocity of the cart is separate, and then they get frustrated because they can't figure out what the velocity of the other object is. But because they stuck, they have to have the same velocity. So from here, I can just divide both sides by that. So this becomes mass of the clay ball times the velocity of the clay ball all over mass of the clay ball plus mass of the cart equals the velocity of the clay ball cart system. And this was a total of 6 on the top. We figured that out already. Over 1.5, because that's the 0.5 and 1 right there. So that comes out to be 4 meters per second as our answer. Okay. That's how you do this problem. It's pretty simple. My challenge to you guys, and this is a fun YouTube channel challenge, is I have these other two problems, problem number 1 and problem number 2. I'm saying that they both stick to each other in the same way. In problem 1, we have the mass hitting a 2m mass, and they're coming towards each other. So the 2m isn't stationary anymore. It's actually, they're both coming towards each other. So find the final velocity in terms of m and 2m. And if you want, share in the share it in the YouTube chat or the YouTube comments. For problem number 2, I have the clay ball coming in, hitting another cart hitting the cart that's going the opposite direction, but it's going 2B, so it like catches up and sticks to it. So I want you to also feel free to share what the final mass of these objects would be. I didn't give you guys velocities or masses, so I want these in terms of m's and v's. But go ahead and see if you can figure those out and share them in the YouTube comments. All right, thank you. Short video. I hope. Was it a short video? Yeah, it was a short video. All right, see ya.